Imagine you're lying on the grass, staring at the sky. The world around you feels vast, trees rustling in the breeze, buildings towering nearby, the horizon stretching out endlessly. But that's just the beginning. Today, we're embarking on an enhanced visual odyssey to answer one of humanity's greatest questions. How big is the universe? We'll start right here on Earth and zoom out, step by step, multiplying our view by powers of 10. Each jump will reveal wonders beyond imagination, from our tiny blue planet to distant galaxies billions of light years away, incorporating deeper insights, fascinating historical notes, and stunning visuals to bring the cosmos to life. This isn't just about size, it's about perspective, history, and discovery. The universe is so immense that our minds struggle to grasp it. Yet humanity has pieced together its scale through centuries of observation, from ancient astronomers like Ptolemy to modern telescopes like the James Webb Space Telescope, launched in 2021 and still unveiling secrets in 2025. By traveling through these scales, we'll see how everything connects, from the atoms in your body, forged in stellar explosions, to the cosmic web that holds it all. Buckle up, we're about to leave Earth behind, with added layers of scientific wonder and visual aids to make the journey even more immersive. We begin at the human scale, 1 meter, 10 to the power of 0 meters. That's roughly the width of your arms outstretched, or the height of a child. At this level, you're surrounded by everyday wonders, the blades of grass beneath you, insects buzzing about, and the air molecules you breathe, numbering about 10 to the power of 25 in a single lungful. Now, let's expand to 10 meters, 10 to the power of 1 meters, the size of a small house or a basketball court, where friends gather and stories unfold. At 100 meters, 10 squared meters, we're looking down on a neighborhood, with streets bustling with life and cars zipping by like tiny models. Keep going to 1,000 meters, 10 cubed meters, where we see a whole city sprawl below, skyscrapers piercing the sky, rivers winding through urban landscapes, and parks offering green respites. 10 times farther, 10,000 meters, 10 to the power of 4 meters, and mountains come into view, their peaks snow-capped and ancient, shaped by tectonic forces over millions of years. At 100,000 meters, 10 to the power of 5 meters, continents outline against oceans, revealing the patchwork of land masses that have drifted apart since the supercontinent Pangaea broke up 200 million years ago. Now, 1 million meters, 10 to the power of 6 meters, that's a megameter, about the distance across the United States from coast to coast. Earth starts to curve noticeably, hinting at its spherical nature, a fact first calculated by Eratosthenes in ancient Greece using shadows and geometry. Push out to 10 million meters, 10 to the power of 7 meters. Behold, our planet in full. Earth is roughly 12,742 kilometers across, about 1.27 times 10 to the power of 7 meters. This blue marble, home to over 8.1 billion people, as of 2025 estimates, oceans teeming with diverse life from coral reefs to deep-sea vents, and vast deserts like the Sahara, hangs fragile in the void. From here, you can see the atmosphere as a thin veil, just 100 kilometers thick, protecting us from the harshness of space and enabling phenomena like auroras caused by solar winds interacting with our magnetic field. Zooming further to 100 million meters, 10 to the power of 8 meters, We pass geostationary satellites at 36,000 kilometers, which beam TV signals and GPS data to our devices below. At 384 million meters, about 3.84 times 10 to the power of 8 meters, there's the Moon, our closest companion, orbiting Earth every 27.3 days. It's 3,476 kilometers wide, scarred by craters from ancient asteroid impacts, some as large as 2,500 kilometers across, like the South Pole Aitken Basin. The Apollo missions, 1969 to 1972, showed us its dusty regolith surface, where astronauts left footprints that remain undisturbed due to the lack of atmosphere. From this distance, it's a pale dot against Earth's glow, and the interplay of light creates phases we observe from the ground. The journey from Earth to Moon takes light just 1.3 seconds, yet it took humanity's ingenuity 3 days to reach with chemical rockets, though future missions with advanced propulsion could cut that time. This is the Earth-Moon system, a cosmic dance that's shaped tides, stabilized Earth's axial tilt for stable seasons, and inspired myths from werewolves to lunar deities across cultures. But we're just getting started. The universe dwarfs this tiny pair, and recent discoveries like water ice in lunar craters, confirmed by NASA's LaCrosse mission in 2009, hint at potential resources for future space exploration. At 1 billion meters, 10 to the power of 9 meters, a gigameter, we enter the realm of the Sun. Our star is 1.39 times 10 to the power of 9 meters across, a blazing fusion furnace converting 600 million tons of hydrogen into helium every second, powering all life on Earth through photosynthesis and weather patterns. The distance from Earth to Sun is 150 million kilometers, or 1.5 times 10 to the power of 11 meters, 1 astronomical unit, AU. Light takes 8 minutes and 20 seconds to cross this gap, meaning we see the Sun as it was moments ago. Here are the inner worlds. Mercury, closest to the Sun at 39 cents, a rocky inferno with temperatures swinging from minus 173 degrees Celsius to 427 degrees Celsius, pockmarked by craters and featuring the Calorus Basin, one of the largest impact features in the solar system. Venus at 72 cents, shrouded in thick sulfuric acid clouds, hotter than a pizza oven at 464 degrees Celsius due to a runaway greenhouse effect, a cautionary tale for Earth's climate. Then Earth at $1 Australian, our oasis with its unique plate tectonics recycling the crust. Mars at $1 Australian and 52 cents, with its ancient riverbeds, massive Olympus Mons volcano, 3 times Everest's height, and polar ice caps hinting at past water flows, now explored by rovers like Perseverance, still active in 2025, searching for signs of ancient life. Pushing to 1 trillion meters, 10 to the power of 12 meters, a terameter, we reach the gas giants. Jupiter at $5 Australian and 20 cents is 143,000 kilometers wide, 11 Earths across, with its Great Red Spot, a storm twice Earth-size raging for at least 400 years, observed since the 17th century. Saturn at $9 Australian and 50 cents boasts rings spanning 280,000 kilometers, made of countless ice and rock particles, possibly remnants of a destroyed moon, and explored in detail by the Cassini mission, 2004 to 2017. Uranus and Neptune, at 19 and 30 Australian dollars, are ice giants with methane atmospheres giving them blue hues, extreme tilts causing bizarre seasons, and fierce winds up to 2,000 kilometers per hour. Beyond, at 39 Australian dollars, lies Pluto, now a dwarf planet. In the Kuiper Belt, a ring of icy bodies extending to 50 Australian dollars, or about 7.5 times 10 to the power of 12 meters. Pluto's heart-shaped Tombaugh Regio, revealed by New Horizons in 2015, features nitrogen ice plains. The Voyager probes, launched in 1977 and still transmitting data in 2025, have crossed the heliopause at around 1.2 times 10 to the power of 13 meters, entering interstellar space where the sun's influence wanes. Our solar system is vast, about 1 to 2 light-years across if you count the Oort cloud, a distant comet reservoir up to 10 to the power of 14 meters out, source of long-period comets like Hale-Bopp. But compared to what's next, it's a speck in the interstellar ocean. At 1 quadrillion meters, 10 to the power of 15 meters, a petameter, we leave the sun's influence. 1 light-year is 9.46 times 10 to the power of 15 meters. The distance light travels in a year at 300,000 kilometers per second. The nearest star, Proxima Centauri, is 4.24 light-years away, or 4.01 times 10 to the power of 16 meters. It's a dim red dwarf, flaring unpredictably, with an exoplanet Proxima b in its habitable zone, potentially rocky and Earth-sized, though battered by stellar winds, discovered in 2016 and a target for future telescopes. Zoom to 10 to the power of 17 meters. Sirius, the dog star, shines at 8.6 light-years, twice the sun's mass, blazing blue-white and part of ancient Egyptian calendars. Vega, 25 light-years out, spins so fast, every 12.5 hours, it's oblong, and was the first star, besides the sun, to be photographed in 1850. These are our cosmic neighbors, but the voids between are immense, mostly empty space, with occasional rogue planets ejected from systems or diffuse gas clouds. Interstellar travel remains a dream. Even at 1% light speed, reaching Proxima would take over 400 years. At this scale, the universe feels lonely. It would take our fastest probes, like Parker Solar Probe, reaching 700,000 kilometers per hour, tens of thousands of years to reach these stars. Yet, radio signals, like the 1974 Arecibo message or the Voyager Golden Records, race across at light speed, carrying humanity's hello to the void, potentially detectable by any advanced civilizations. Expanding to 1 quintillion meters, 10 to the power of 18 meters, an hexameter, we see stellar nurseries. The Orion Nebula, 1,344 light-years away, spans 24 light-years, birthing stars from collapsing molecular clouds, with protoplanetary disks hinting at forming worlds, imaged spectacularly by Hubble and JWST. This is the interstellar medium, thin hydrogen gas, about 1 atom per cubic centimeter, dust grains, and magnetic fields threading the galaxy, recycling material from exploded stars. Supernovae like SN 1987A enrich this with heavy elements essential for life. At 10 to the power of 20 meters, our galaxy emerges. The Milky Way is a barred spiral, 100,000 to 180,000 light-years across, or about 1.9 times 10 to the power of 21 meters. It contains 100 to 400 billion stars, with our Sun in the Orion Arm, 26,000 light-years from the center, amid a sea of cosmic dust that obscures views in visible light but reveals treasures in infrared. The heart holds Sagittarius A*, a supermassive black hole 4.3 million times the Sun's mass, imaged directly by the Event Horizon Telescope in 2022, with an event horizon 24 million kilometers wide. Around it, stars whirl at 4,000 kilometers per second, defying intuition. The galaxy's arms, Scutum Centaurus, Perseus, spiral out, dotted with star-forming regions like the Eagle Nebula's pillars of creation, eroded by stellar winds. The Milky Way is flat, just 1,000 light-years thick at the arms, but surrounded by a spherical halo extending 300,000 light-years, home to globular clusters like Omega Centauri. Invisible dark matter, 5 times more abundant than normal matter, holds it together against centrifugal force, inferred from rotation curves first noted by Vera Rubin in the 1970s. We orbit the center every 225 million years, a galactic year, during which dinosaurs rose and fell. From edge on, it's the luminous band across our night sky, revered by indigenous cultures as a river of souls. From above, a cosmic pinwheel of light and shadow. This is home to potential life, with over 5,000 exoplanets confirmed by 2025, supernovae forging elements like gold and iron, and mysteries like fast radio bursts, intense energy pulses possibly from magnetars. Yet, the Milky Way is one of trillions of galaxies in the observable universe. At 10 to the power of 22 meters, a zetameter, we see the local group. About 100 galaxies, updated estimates, bound by gravity, spanning 10 million light-years or 9.46 times 10 to the power of 22 meters. Our Milky Way and Andromeda dominate, with the latter boasting 1 trillion stars. Andromeda, 2.5 million light-years away, is similar in size but more massive, visible to the naked eye as a fuzzy patch. It's hurtling toward us at 110 kilometers per second. In about 4.5 billion years, they'll merge into Milkomeda, a spectacular cosmic collision reshaping both into an elliptical galaxy. Those stars will rarely collide due to vast spaces. The Magellanic Clouds, irregular galaxies at 160,000 and 200,000 light-years, are satellites being torn apart by the Milky Way's gravity, trailing streams of gas. Triangulum, the third largest, lies 3 million light-years out, potentially interacting with Andromeda. Dwarfs like Leo I and the recently discovered Antlia II add to the mix. Many discovered via surveys like Gaia, mapping billions of stars since 2013. Beyond, at 10 to the power of 23 meters, the Virgo cluster appears, 54 million light-years away, with over 1,300 galaxies, core count, dominated by giants like Messier 87, whose black hole was the first imaged in 2019. It's the heart of the Virgo supercluster, pulling our local group at 600 kilometers per second via the Great Attractor, a gravitational anomaly partially obscured by our galaxy's dust. Clusters like this are hotbeds of galaxy evolution, with intracluster gas heated to millions of degrees, emitting X-rays. At 10 to the power of 24 meters, a yottameter, superclusters emerge. Our local supercluster, formerly Virgo supercluster, spans 110 million light-years, containing tens of thousands of galaxies. The cosmic web, galaxies align in filaments, walls, and sheets, separated by vast voids up to 500 million light-years across, nearly empty save for sparse gas. The Sloan Great Wall stretches 1.37 billion light-years, one of the largest known structures, mapped by the Sloan Digital Sky Survey. This web formed from quantum fluctuations in the early universe, amplified by inflation, a rapid expansion 10 to the power of -35 seconds after the Big Bang. Dark matter scaffolds these structures, with ordinary matter following suit. Finally, 10 to the power of 26 meters, the observable universe. Its diameter is about 93 billion light-years, or 8.8 times 10 to the power of 26 meters, encompassing at least 2 trillion galaxies and 10 to the power of 24 stars, based on Hubble and JWST deep fields. Why so big when the universe is only 13.8 billion years old? Expansion. Space itself stretches, governed by the Hubble constant, around 70 kilometers per second per MPC in 2025 measurements, carrying distant galaxies away faster than light. No violation of relativity, as its space expanding. The edge is the particle horizon. Beyond, light hasn't reached us yet, and the cosmic microwave background, CMB, marks the farthest we can see. Relic radiation from 380,000 years post-Big Bang, mapped by Planck satellites showing tiny anisotropies that seeded galaxies. Dark energy, discovered in 1998 via supernova observations, accelerates this expansion, comprising 68.3% of the universe's energy budget, dark matter 26.8%, ordinary matter just 4.9%. From here, Earth is invisible, a mote in cosmic vastness, lost among countless worlds. Speculatively, the total universe could be infinite, with multiverses proposed in theories like eternal inflation, where bubble universes spawn endlessly. Quantum gravity and string theory hint at even grander scales, but these remain theoretical.